Hello viewers, in today's class we are going to discuss one important definite integral involving Signum function, right? So here we have to integrate this function, that is e raised to minus greatest integer x and signum of x over 2, right? So let us start. So here let us first call this integral as I, right? Now before proceeding further, let us first define this function signum of x over 2, right? So let us take the function signum of x over 2 as phi x, right? So phi x is equal to plus 1, right? Because we know that from the definition of signum function, signum of x is equal to plus 1 whenever x is greater than 0, right? So here we have x over 2 in place of x, right? So signum of x over 2 is equal to plus 1 whenever x over 2 is greater than 0, right? And signum of x over 2 is equal to 0 whenever x over 2 is equal to 0, right? And signum of x over 2 is equal to minus 1 whenever x over 2 is less than 0, right? So this we have taken from the definition of signum function, because signum of x is equal to plus 1 when x is greater than 0, and signum of x is equal to 0 whenever x is equal to 0, and signum of x is equal to minus 1 whenever x is less than 0, right? So here we have used this definition of signum function. So here for this x we have here x over 2, right? Okay, so now here we have denoted the function signum of x over 2 by phi of x, right? So now we can write phi over x is equal to plus 1 whenever x over 2 is greater than 0, or we can solve this inequality as x greater than 0, right? And phi x is equal to 0 whenever x is equal to 0, because when we solve this equation x over 2 is equal to 0, we get x equal to 0, right? And phi of x is equal to minus 1 whenever x is less than 0, right? Okay, so now here if we take the real number line, so here we have minus infinity, here we have plus infinity, and here we have the point, say minus 1, because here we have to integrate this function from minus 1 to infinity, right? So phi of x is equal to plus 1 whenever x is greater than 0. Now let us take here x equal to 0, right? So in this part we have x is less than 0, and here in this part we have x is greater than 0, right? So what does this imply? It implies that phi of x takes the value plus 1 whenever x is greater than 0. So right, so here we have the open circle, because here phi of x is equal to 0 whenever x is 0, and all those values of x which belongs to the interval 0 to infinity, we have x greater than 0, right? So here we have the value of phi of x is equal to plus 1, right? And for the interval in which x belongs to minus infinity to 0, in this interval uh, phi of x takes the value minus 1, right? Okay, so this is the situation here, and now let us split this integral. So now I can be written as a sum of two integrals, right? The first one is from -1 to 0, because in this interval from -1 to 0 x is less than 0, right? And then we have the integral from 0 to infinity, right? So we'll split this integral as a sum of two integrals. One is from -1 to 0, and here the integrand is e raised to greatest integer x, and signum of x over 2 can be replaced by the function phi of x, right? And here we have dx, right? And the second integral is from 0 to infinity. So here we have the integrand e raised to greatest integer x, and the function signum of x over 2, which can be replaced by phi of x, right? Okay, so now here see, when x belongs to this interval, that is from -1 to 0, x is obviously less than 0. So this phi of x will take the value minus of 1, right? And when x belongs to the interval 0 to infinity, then obviously x is greater than 0, right? And in that case phi of x will take this value plus 1, right? So now this integral I can be written as integral from -1 to 0 e raised to minus greatest integer x, and for phi x we have -1 here, dx plus 0 to infinity e raised to minus greatest integer x, and for phi x we have plus 1, right? Okay, so now in these two integrals we have the greatest integer function which is greatest integer x. So let us now utilize the definition of greatest integer function, right? So when x belongs to this interval from -1 to 0, then obviously the value of greatest integer x is equal to -1, right? And when x belongs to this interval, that is x is greater than or equal to 0 but less than infinity, we have to now consider all the positive integers which lies between 0 to infinity, right? So here we can now take this integral as -1 to 0, and here we have e raised to minus and -1, because when x lies between -1 and 0, the value of greatest integer x is equal to -1. This is due to the definition of greatest integer function, and here we have -1 dx, and now we have to split this integral into the sum of those integrals in which we have the integral points, right? So we'll split it in the next step. So let us write it as 0 to infinity e raised to minus x and dx, right? So now this integral is -1 to 0, and here e raised to plus 1, and we have dx. Here we have this negative sign, and now we can write it as 0 to infinity e raised to minus greatest integer x dx, right? So now viewers, the value of this integral is minus, and the integral of x dx is x. Simply here we have e, because e is the constant, and here we have x. The limits are from -1 to 0, and now we can write this integral as a sum of these integrals, that is 0 to 1 e raised to minus greatest integer x dx, and plus 1 to 2 e raised to minus greatest integer x dx, plus 2 to 3 e raised to minus greatest integer x dx, and so on, right? Because here the limits are from 0 to infinity, and between 0 and infinity we have the positive integers as 1, 2, 3, 4, and so on. So we'll split this integral as a sum of integrals from 0 to 1, then from 1 to 2, 2 to 3, 3 to 4, and so on, right? So up to infinity, right? Okay, so now we can further write this expression as this expression is minus e, and here we have 0 minus minus 1, and here we have 0 to 1, and when x lies between it is 0 to 1, then the value of greatest integer x is 0. So we have e raised to minus 0 dx, right? Then we have the second integral, that is from 1 to 2. So when x lies between 1 and 2, then the value of greatest integer x is 1. So we can now write it as 1 to 2 e raised to minus 1 dx, right? Then we have the third integral. So now we have the integral from 2 to 3, and see when x lies between 2 and 3, then the value of greatest integer x is 2. So we have e raised to minus 2. For greatest integer x we have 2 here, and dx, right? And the fourth integral is from 3 to 4, right? So when x lies between 3 and 4, then the value of greatest integer x is 3, right? So we have the integral from 3 to 4 and e raised to minus 3 dx, and we'll continue this, and this will go up to infinity, right? Okay, so now we have to evaluate these integrals, and here we'll obtain a geometric progression, and let us see how we will get a geometric progression. So this term is now minus minus plus, so we have minus e, and here we have e raised to minus 0 is e raised to 0, which is 1, so we have 0 to 1 dx, right? And the second integral is e raised to minus 1, 1 to 2 dx. Then we have e raised to minus 2 and integral from 2 to 3 dx. Then we have e raised to minus 3, integral from 3 to 4 dx, and so on, right? Okay, so now we have minus e here, and here we have x. Limits are from 0 to 1, and then we have e raised to minus 1, and the integral of dx is x. Limits are from 1 to 2, then we have e raised to minus 2, and the limits are from 2 to 3. Then we have e raised to minus 3, the limits are from 3 to 4, and so on, right? So now we can write it as minus e. Here we have 1 minus 0, that is simply 1, and here we have e raised to minus 1, and this is 2 minus 1, so again we'll have 1, and then we have e raised to minus 2, 3 minus 2, again we'll have 1, and e raised to minus 3, again we have 4 minus 3, that is 1, and so on, right? Okay, so now we can rewrite this series as minus e plus 1 plus e raised to minus 1 plus e raised to minus 2 plus e raised to minus 3, and so on, right? Now viewers, we see that this constitutes a geometric progression, right? An infinite geometric progression, and we know the sum of an infinite geometric progression as S infinity is equal to a over 1 minus r, where a is the first term and r is the common ratio. So now here this is the infinite geometric progression, and the first term is 1 here, because the series, the infinite geometric progression starts with 1, and the common ratio, that is r, is given by second term divided by first term, that is e raised to minus 1 over 1, right? And that is equal to 1 over e, right? So now this integral I can be written as, see, this is the term minus e, and then we have this geometric progression, which is a over 1 minus r, right? So we have minus e plus, for a we have 1, and for r we have 1 over e, right? Now we can simplify it. So this is minus e plus e over e minus 1, right? So now we can further simplify it by taking the LCM. So we have e minus 1 here, and we have minus e times e minus 1 plus e, right? So now this is minus e square plus e over e minus 1, right? And now this can be written as minus e square plus 2e over e minus 1, right? Which can further be written as taking e as common, so we can write it as 2 minus e over e minus 1, right? So viewers, the value of this integral, which comprises of the Signum function and the greatest integer function, is equal to e times 2 minus e divided by e minus 1, where e is the exponential number which lies between 2 and 3. So this is how we solve this integral.